Okay, so 42 says two force vectors. F1 has an x component of 3, so we'll make F1 red. So I have an x component of 3, and then it tells me a y component of negative 3. So the actual F1 vector is the resultant of these two, which would be this hypotenuse that kind of points down in that direction. This is F1. This is 3 this way, 3 that way. And then I have F2, which will turn green, has a x component of negative 6, so point that way, and a y component of 4.5. So if I wanted to do actual F2, it would be here, kind of pointing up in this direction. That's F2. Then it wants to know, our applied to particle, what third force would make the net or result 0? So just like we were doing before, I kind of take the components by themselves. So in the x direction, so far, I have positive 3, that's F1, the x component, minus 6 is F2's x component, plus some unknown x component that I don't know, and I want to make the net of this thing equal to 0. So I have a relatively simple math problem. Positive 3 minus 6 is negative 3, plus x equals 0. X is positive 3. So F3's x component is going to be positive 3. If I do the same thing in the y direction, F1's y component is negative 3. F2's y component is positive 4.5. I have a third y component that I don't know, that I want to add it and make this whole thing 0. So 4.5 minus 3 is 1.5, plus y equals 0. Y is going to be negative 1.5. So this vector F3 is going to have an x component that's positive 3. It's going to have a y component that's negative 1.5. So if I want to find the actual value of F3, which is going to point down in this general direction, I do Pythagorean's theorem again. I have 3 squared plus 1.5 squared, the square root of that answer. Gives me 3.35. And that would be the magnitude of the third force that would make this whole thing in equilibrium, or in other words, the resultant being 0.